I see. And why do you believe simulation's a good thing in your job?
Well, we work in a very dynamic environment, and what happens is we find that after changes have gone into the system, they don't work as they are supposed to. And it's usually because sometimes someone coded something wrong, but most of the time is we code it and then the client realizes this isn't what I wanted, this isn't how it's supposed to behave, or so it's just generally that divide between what the developer thinks the client wants and what the client actually wants. So having this simulation would help us in two main ways actually. The first one is allowing us to show them the potential behaviors of the system will enable us to identify any problems beforehand and any behaviors which they don't actually want. So this will save us a lot of time and a lot of money, and if you mention money in the finance industry, you will be listened to. And also, sometimes it works perfectly on its own, and then you integrate it into the end-to-end system and it completely buggers up. So this will allow us to simulate that, adding that little piece of the puzzle into it and see how it works end-to-end. So in the long run, it just allows us to be more dynamic, more efficient, and saves us a lot of money and time.
I see. Thank you very much.
Yeah. So in Shell we have a similar problem. We have a scarce resource and lots of demand on that resource. In this project, the scarce resource is a microprocessor, but in the oil industry, the scarce resource is petrol at one of our depots. So the difficulty here is actually allocating that product efficiently to all our customers, and that becomes particularly important when we have natural disasters like hurricanes and we have to decide which customers we're going to serve first. And that allocation problem is currently solved manually, so people intervene manually and they make those decisions. But if we could have an algorithm which could actually optimise that allocations problem, that could be very useful.
The whole field is devoted to the idea that you can do design in an ad hoc way and get things that work, but hopefully you can do better if you sit down and you think and characterize your workload, you model what's going on, and you try to do something optimal within that context. So it's kind of the long way around. It's a lot more work to get to a design that way, but the hope is that because of this, you're going to uncover something surprising, right? In a lot of applications, maybe the short hack will work well. Your intuition is right, and what you think without, doing any math or theory or modeling will work well. But in other situations, there's something surprising, and you're not going to find that if you just, don't take the easy route, take the greedy route of just hacking something up, and you don't do the theory. And so, in some sense, I guess the quote indicates that you want to work, the easy designs you don't need this for, but if you want to do something sort of interesting and research and novel, then it really takes, the modeling